Using classes in Swift. We've used object-oriented programming all year long. With Swift, with the playground feature, it allows us to just try some things out. And so we can actually build classes right here, like we would regularly write the actual files for them, and test just to see some sample ideas. And this is what we're doing this weekend. Rather than building the overhead of a project, as we learn some basic features, we're going to make a couple quick classes and structures. And so a class is an object. And so we have some stuff. We have instances of classes. We do use that in Java all the time as well. And so we have right here, we have simply a class or a struct. We're going to make classes. So we have a class. We give the name of the class, the squiggles to go along with it, just like we did in Java. Again, remember with Swift, though, we don't use public or private, so you don't have to worry about that. And we can have variables inside the class. You define them with values. We will use the init method to initialize or construct that class. And so we'll have a couple different inits. Remember, if we have multiple different inits, we have different set of parameters for them. And so we're going to take that. Just like in Java, classes are references. They are objects, so they pass by reference. So if I change my class, it will change your class. So we want to keep that in mind. So let's go ahead and play with that right now. So we'll say class simple class, and our standard naming convention would apply, where it has a capitalized first letter and every additional letter is also capitalized. We'll have a declaration section just like Java. We declare our variables. So var name is of type string, var age is of type int, and var is tired is of type bool. So we have our declaration section. Notice that we are simply defining the type of what variable they are. We're not assigning values just like we do in Java. We're making this so we have the ability just to define that structure first. For the constructor section, in Swift it's called the initializer, or the init. And so it's the init parens squiggles. And so inside here, we would say that name equals string parens, which is called the string constructor, or string init. And I'm having an error here because I've not initialized all my values. I want to make sure in Java you can get away with initializing only some values. In Swift, you need to initialize all of your data members. So that's why we have that error message right here. Swift requires all data members to be initialized in their init method, or in the init for that object. And so we'll say the age equals -99 for default, and the is tired equals true. Now that I've initialized all of my data members, notice that my error message goes away. So my default init, if I call the default init, we will have the actual creation of it with a bunch of garbage. No one's -99. So again, sometimes we want a default init. Depends on the object itself. I can have an additional init. If we're going to use a convenience init, if we're just wanting to initialize one specific parameter, we have to use the convenience keyword on top of that, which goes before the init keyword. We call our variable init, or call our init thing on that, so we can actually call the original constructor. And then I can reassign that self.name, passing it name. We can't call self. Self doesn't exist until it actually is there. Here's my class. I have a simple class right here where I have a name, age is tired. We've made that class. We have that basic up here. We have our convenience init. And so I can say my var sum self, or sum object, some instance, let's do some instance, equals, and then we're going to create simple class. So we're going to say simple class parens. We initialize it with a simple class. Some instance is a new instance of simple class. Not new, just simple class. Calling it init. Then I want to go and I want to print, and I'm going to do some instance. Yikes. Dot name. Because when I created my instance of some of that, I go up here, and my simple class declaration section, my name is declared as of type string. My init, which I called right here by simply just passing the open parens after the type. What does initialize my name? As a new string object that has what inside it? Nothing! So that was really helpful. So let's try that again. Let's make a new version of this. So var other instance equals, and then do simple class, parens, quotes, and my favorite first name ever, Derf. And I have an error message. We hover over here. I need the label. So I need to say that name is of, Derf is, the variable I'm putting on there is name colon. So name colon, indicate that I'm assigning that to the name variable. So we must call it the type of that inside Swift. We don't do that in Java. So when I call a parameter, I have to actually assign which parameter is being assigned into that. So I'm saying simple class's name parameter, I'm putting as Derf. And now if I print other instance, parens, and I do other instance, dot name, I get Derf printed out. Because I initialize my object up here, using its convenience initializer, creates it with nothing inside it, overrides it with whatever I passed as the name right here, shoving that into self.name. So when I passed it Derf, my printing of my other instance.name prints then Derf for that as well. Now because Swift does not use public/private, I'm simply just accessing that value right here. I can actually make a getter and setter. And that you have an assignment inside your canvas about Swift that I want you guys to take a look at in just a bit. The getters and setters in Swift, there are 3 different ways of doing getters and setters. Normally, if we're making a class inside Swift, we put it inside its own file, just like we would in Java. So this would be inside simpleclass.swift. Swift is a little bit different than Java. We do have to actually attach a parameter name to our value that we're passing it. We'd separate those by commas. So if I make another convenience init right here, and so I'll say another convenience init parens, and we'll do name is of type string, and age is of type int. Self.init again, because it's a convenience init, and then self.name equals name, and self.age equals age. And I also did string with a lowercase s. Fixed. Okay, there we are. So I have my other convenience init now, where it calls the original one. I'm just skipping past that other value, because again, with Swift, you must initialize all your data members inside the constructor. I'm going to go down here. I'm going to call this new convenience init right here. And so I'm going to say var. Notice how I have the name colon and age colon. So this helps me identify what my parameters are indicated inside my own code. So as a programmer, I am helping myself out in the future. Now, Java has a Java vis-a-vis tools like Eclipse has that when you start typing your parameters, it says here's what the method is called inside the header for the method. We've seen that happen inside Eclipse where it's some string or it's other string or something like that. This is why it's really important in your header for your method or your header for your constructor, or in this case in Swift, your header for your init, to make sure that you name your variable something that makes sense. Otherwise, when you call it, if I just left this right here as n and a, my call for this of n colon a colon will make almost no sense. There's no reason to give yourself bad code by default. So in Swift, even more so than Java, we need to make sure we actually name our header variables something that means something. So we want to make sure we do a good job. So I'm going to undo all that garbage I just did, because I don't want to leave my code bad. In Java, we had a public class header, and our classes were public, so it would look like this. So Java version, public class, some class. We have our declaration section, and then we would have our constructors, and we have our methods. Our declaration section will be private. Our constructors would generally be public. They have the same name as the class, and our methods would be just like we did methods just a few minutes ago. Going over into the Swift to make a class, we would say class is the keyword. Again, we don't use public or private. Then we keep the same naming convention. In Swift, we would name this our file. Since we're using the playground, though, we're just going to build it right here, practice class. We have our regular class structure. We have these squiggles that we're going to keep aligning with that. And we'll have our declaration section. Now, in Swift, however, our declaration section is a little bit different than our declaration section in Java. Again, we don't have a visibility to worry about. A var favorite food is of type string. We'll say a var number of skateboards is of type int, capital I for int. Remember that. And we'll say var has broken bone is of type bool. So we have our practice class. It has 3 data members in it. These data members belong to the object just like they do in Java. However, in Java, we would have a constructor, and that would be the same name as the class. In Swift, instead of a constructor, we have our init section. So we have the word init, and then if we want a default init, it's just open close parens, just like in Java. And in init, we immediately have an error right here, because in Swift there is a rule. If you have a data member in your class, it must be initialized in your initializer. AKA, init has to give values to all of these data members. So we've been doing that in Java all the time, but in Swift you must do it. It literally won't compile unless you actually initialize all your data members. So the order doesn't matter, but I always like to keep it done in the original order in the first place. And so we'll say favorite food equals, and I can do string parens. That'll do the string initializer. What's it going to put inside it? Blank. Nothing will go in there. I still have an error because I still have 2 other values to put in. My default constructor, or default init, number of skateboards equals, and I could do even the int init. And I could say has broken bone equals bool init. So if I want to go see this method or this thing in action, let's take a look at that. I can make one right here. So I'm going to say var sample instance equals practice class, and I call it the init, just like that. Notice that I do not have a keyword of new. I'm just creating an instance of the practice class right now by calling the name of the class and then the open close parens that calls its default init. And I can say print parens, and then let's say sample instance dot favorite food. And what does it print? A blank line. Why? Because what's inside favorite food?
Nothing.
Just a blank string. Instead of favorite food, I print has broken bone. Actually, Control Z does not do that. So print parens sample instance dot has broken bone. False. The default value of a Boolean is false, just like Java. So bool default is false, Boolean default in Java is false. But what am I doing here? I'm just referencing there's no get. One of the ways I can do a getter in this is I can simply just access the data member. Now I can make them private-ish, like we do in Java. Since it is a different visibility structure, we'll talk about that. That's actually part of your assignment on getters and setters. You can make it so you can't set the value inappropriately, but you can just retrieve the value. So like we're talking about the idea of getters and setters, I can have a built-in getter and setter simply by referring to the data member. So it has a just default access. Now if I want to control access to my values, to make it so that there is basically information hiding, or the abstraction of data that we see in Java, and we try and do in object-oriented programming, we can force it so you have a specific method to call to set those values. You can't just simply override it. We'll talk about that more later. That's actually, like I said, part of your homework assignment. But you can see that we can actually access it right here. So we've got that right there. Let's go ahead, though. Let's add to our class. Let's add a new init. Now, we've made other inits in class. What we're going to do with this is we can have a convenience init, so we only have to specify one parameter, the rest of them can simply just be built. And so by using the convenience keyword, and I will pass it, let's say we'll say has broken bone is of type bool. And so if to use the convenience keyword that says I'm going to use the original init, so I'm just going to call self.init at the first. And then I will then call after that, I will say self dot, not this dot, has broken bone equals has broken bone. And so the convenience init allows me to call to initialize it using, I'll use the default constructor to start off. And then I will pass it a Boolean variable right here to call that at that point. And so let's see that one in action. We'll go down here. And we'll say that var other instance equals practice class parens. And if I just pass it true right here, I have now this is where I was thinking it, so the init is different. I have it right here on the init. I must actually have a label. So this is different from Java. Java constructors and methods are the same. You don't have to give labels of that. In Swift, we have every parameter of the init needs its label. So I need to have that. This is going to be going to has broken bone. Label value of true. So I'm making it at that point. And so I can say other instance dot has broken bone. And that other instance, I'm printing has broken bone, and we can see that it is true as well. We have this lovely eye indicator right here. We can see inside that object. Its number of skateboard has no value. Its favorite food is set to blank. And its has broken bone is set to true. We can click the plus sign next to it right here. That says when I create that instance, I can see my favorite food, tasty wheat. My number of skateboards default value is 0 because it's an int. And my has broken bone is set to true. And so I access this by going over to my object over here on my playground section. I click on the plus sign. The question was, what exactly is has broken bone :true doing? When I'm using the convenience init and I have a labeled parameter, as I do right here on bool. So my parameter has the label with it. So has broken bone is the label's name. It's of type bool. When I call that constructor or that init, I must specify which parameter I'm passing that value to in the init. So the constructor or the init, the init in Swift is different from just a method. When I go back over here to my methods playground and my word string age int values double, when I was playing at that playground, I did not have to pass a label for that first parameter. But each subsequent parameter required that label attached to it. However, if I'm going to go to my init one, so my classes in Swift, because my init one requires the use of labels for all parameters. So if I were to make another init that would say has broken bone and one that has one for favorite food. So I'd have favorite food colon string. I'd have to have has broken bone colon true comma favorite food colon whatever value I'm passing. So this is where the idea that on Swift or in Swift as a language, we want to make sure that our parameter header or the label for it is clearly indicating what we're doing. Because when I call it, in this case, I'm calling an instance of practice class, passing it has broken bone true. In this instance right there, has broken bone is set for false. I change it to true, it becomes true. This one, when I create practice class, it initializes that value immediately at true, as we can see right here by looking at the results of that on our code. If I go to practice class right here, we have that little I right here first. And to the I have that plus sign where I can show the result. I click on that show result, and when I create that object, my favorite food is set to blank. My number of skateboards is set to 0. And my has broken bone is now set to true because I changed that value right here. If I go look at it right here on this one, and I initialize that, I expand that one out. So when I first create that object, this is a good question, by the way. So to access it, first I click at the plus sign. It brings there. My favorite food value starts off at 0 at blank. Skateboards is 0, and has broken bone is false. I can hide those results right there. If I move my cursor properly. I can hide those results, click on that, it'll collapse it back out. And then that same object right here, I've changed it at this point. So when I look at it up here on this line, when I first create it, it has broken bone is set to false. At this point, sample instance though, I've changed it to be true. So now it has broken bone has true. And so this is a great way, this is a great feature. We can actually see the contents of our objects as we write our code. And you access that by going over here, clicking the plus sign, and it'll show the result of that. In this case, there's nothing to show because it's just print, so it doesn't have internal objects to look at. But when it has a type, like this in the case of practice class, it's one of our instances, we can expand that out and see what's inside it. And so that's and you could further expand that out to go inside if there was something to actually look at in there. And we can also just do the quick little hover over method by clicking the eyeball.